Step right up, ladies and gentlemen, and behold the marvel of the century. Are you a connoisseur of Gomoku, the ancient game of strategy? Does the thought of face-to-face interaction send shivers down your spine, but you don't want to sacrifice your love for tangible gaming experience and join those phone-using peasants? Do you want a conversation starter in your living room, but you don't want a still static piece of junk? Fear not, for we have the solution you've been dreaming of. Introducing the one, the only MaGomoku. With MaGomoku, you can indulge in nostalgic tangibility while simultaneously embracing the digital age developed by none other than the prodigious minds of Chen, Pan, and Wan. From now on, your Gomoku experience will never be the same again. Our state-of-the-art magnetic levitation device, Disclaimer, the maglev technology has been halted due to technical difficulty. All maglev components have since been replaced with electromagnet. No refund will be issued for any pre-orders or previous purchases. Effortlessly glides the pieces across the boards, mirroring your opponent's moves with pinpoint precision. No more squinting at sad small screen. Watch your victories unfold in glorious real-life action. But wait, there's more! Your brilliant move will also be automatically captured by our custom-built Hall Effect Sensor Matrix PCB. No matter where your opponent is in the world, you can always show them who's boss. But hold on to your hats, folks, because there's no cheating allowed in this neck of the woods. Our real-time game integrity check ensures a level playing field for all, catching those sneaky cheaters red-handed using the same custom-built PCB. And the cherry on top? Our guilt-free design and manufacturing process mean you can enjoy MaGomoku with a clear conscience, knowing you've taken the moral high ground without worries about ethical dilemmas. Now, I'm going to pass the mic to our technical advisors to talk about the technical details and development process of each subsystem in our product.
Hello guys, I am Chief and I am the head of software development department here at MaGomoku. I am right now introducing our solution approach to you guys. As clearly stated in the diagram, the system consists of two parts, the board and the web application. So the board consists of four subparts, which is the movement system that consists of two gantries and the electromagnet that drags the pieces along the way. And also the detection and locking system where there is a matrix of Hall effect sensor that can detect whether there's a piece placed onto that spot. We also have permanent net magnets that's above the Hall effect sensor to lock the pieces in place. We also have the feeding system where there are stepper motors to sort of push the piece from the piece container onto the board so that it can be grabbed by the electromagnet in the movement system. In coordination of these three processes is our processing unit where we use telemetrics as the interface to control the two boards of Arduino. So that telemetrics layer is wrapped by a Python Flask server, which serves as a communication hub in between the board and the web application. So moving forward to our web application side, the backend is implemented using Django and SQLite. So the Django is in communication with the Flask server in exchange of data updates of the board and the game state, which is also implemented in Django and front-end HTML and CSS. The front-end and the back-end communicates using the Ajax API calls asynchronously in order to update all the data reflected through the back-end to the front-end UI system. That's pretty much our solution approach in a nutshell.
Hello guys, I'm Sizhe Chen. I'm here to introduce the fourth subsystem of MaGomoku. The first subsystem is the movement system, which utilizes electromagnet to attract magnets embedded in gold pieces. The electromagnet is then mounted on an XY gantry, which is composed of two linear actuators that move along the X and Y axis. This allows us to do precise movement of the gold pieces to their designated location. The next subsystem is detection and locking. Before I delve into detection, allow me to give a brief explanation of what a Hall effect sensor is. A Hall effect sensor is a device that is used to measure the magnitude of a magnetic field. When there's a change to the magnetic field, a voltage difference perpendicular to the current and the magnetic field is generated across a conductor. Therefore, using this phenomena, we're able to determine the varying magnetic field caused by the movement of the piece, and therefore determine its exact location. In MaGomoku, our detection system employs 3 custom PCBs. Each consists of a 3x9 Hall effect sensor matrix, connecting to 2 16-channel analog multiplexer. Together, the 3 PCBs construct a whole 9x9 Hall effect sensor matrix that scans through the entire board to read the strengths of the different magnets within black and white gold pieces. And under each layer, we use small permanent magnets to fix placements of the piece, and therefore it will give us more accurate detection results. The feeding system is consisted of a vertical magazine for holding gold pieces and the stepper motor that is responsible for pushing out the pieces to be retrieved by the electromagnet. This allows the total autonomy of the system when the remote player is playing.
For the software side, we use Django as the backend and HTML, CSS as the front end to achieve the game state and the UI. And we also use telemetrics package to control, which is a Python language package to control the 2 Arduino boards that does the Hall effect sensor detection as well as the gantry movement system. So the challenge here is the interaction in between the data that's been collected and updated on the Arduino side in syncing communication with the backend Django server. So to do that, we wrapped all the telemetrics Arduino side code into a Flask server, and we defined API endpoints in between. And also we forked 2 processes at the Arduino side to do the Hall effect sensor piece detection as well as the gantry movement system in order to do that.